the agenda. All right, welcome everyone. Can you still see my screen?
Yes.
Great, thank you. Welcome everyone to the Hawaii Aquaculture Tech and Research Brown Bag, sponsored by NELHA and the Hawaii Aquaculture Collaborative, which is facilitated by the University of Hawaii Sea Grant College program. Our usual housekeeping, the recording of today's session.
The ghost pepper gals.
Jean, I think you're muted.
Okay, great. Our usual housekeeping, the recording of today's session and slides will be posted on our website, hiaquacollab.org. Feel free to introduce yourself in the chat and use the hand raising feature or the chat to ask questions and make comments during our discussion. For those of you here for the first time, this is the Tech and Research Working Group of the Hawaii Aquaculture Collaborative. We're here to provide a space for Hawaii aquaculture industry leaders and stakeholders to collaborate on technology and research solutions. Our format is about 10-15 minutes of background and a problem the industry is trying to solve, and the rest of the time will be for questions, discussions, and possible solutions. Our schedule is every second Wednesday of each month at noon. If you have a tech and research problem you'd like to solve, please contact Kai. And for more info, please see our website. Let's see, so next month is an exception to our schedule. It would be on this third Wednesday, January 18th at noon. John Dobovan of Kula Haven Farms will be discussing and seeking solutions for how to get funding for aquaculture. One quick update, we are currently writing a NOAA workforce development grant focused on internships and building an aquaculture talent pipeline in Hawaii. Please contact my colleague Annie if you're interested in hosting interns and building your workforce. And now let's get to our main event. We'd like to welcome Sita Ekaputri, a PhD candidate from the University of Hawaii Department of Natural Resources and Environmental Management. Sita has her bachelor's degree in statistics from Bogor Agricultural University and her master's degree in economics from the University of Indonesia. She's here today to help us understand and discuss the cost of producing aquaculture feed using local ingredients in Hawaii. Welcome, Sita.
Thank you so much, Jean, for the opportunity to be back in this important venue again. Before I start, let me share my presentation. Okay, and then, okay. Can everyone see my slide now?
Yes.
Okay, perfect. Well, thank you. Aloha, everyone. First of all, I hope everyone is doing well and actually are ready to enjoy the bit of a break during the holiday season, despite of the flu season that has been going around. As you can probably hear from my voice too, I caught a flu a couple of days ago and I've been recovering. So apologies in advance if there might be some coughing during my presentation, but I'll try my best to be clear in my explanation. So my name is Andini Desita Eka Putri, or you can call me Sita. I'm currently a PhD student from the University of Hawaii at Manoa under the Department of Natural Resources and Environmental Management. Currently, I'm also working with the Center for Tropical and Subtropical Aquaculture as a graduate assistant for the past 2 years under a feed mill study that is led by Dr. Chen Sheng Li. And there are actually some team members here as well, including Dr. Bradley Fox and Dr. Armando Garcia Ortega. So as I said, last year, I had the opportunity also to share our findings from our study. And I'm very pleased that today we have the opportunity again to share our next findings of this importance of feed demand in Hawaii. Today, my presentation will be titled, what would it cost to produce aquaculture feed using local ingredients in Hawaii? So before I start, I would like to just give a heads up that when we said local feed ingredients, we are coming with not the intention of saying that we will use 100% of local ingredients, because as of now, until now, we cannot find enough quantity to replace the whole local feed ingredients. So here we mean just like a portion of the local feed ingredient. Okay. I'll skip the overview slide just because we have a very short amount of time. So as we all know, Hawaii heavily relies on imports, including food. And from the latest statistics, we know that Hawaii imports on seafood has increased even more from previously around 50%, I believe, and now the latest statistics show it's 66% to meet the food demand in Hawaii. This includes the local demand and the tourism demand. So one way to address this is, of course, trying to increase our production through one of the ways to aquaculture production in Hawaii. And we've seen an increase of production in Hawaii, but unfortunately, it has been hindered by the high cost of imported feed. So given this and considering the need for affordable feed, CTSA conducted this study to assess the economic feasibility of aquaculture feed production in Hawaii. Several researchers have been implemented, of course, to identify the potential feed ingredients, including a couple months ago where Dr. Armando also shared with you all about the potential of the feasibility of using local feed ingredients, which focuses on the nutritional composition. But today, our study looks more at the cost aspect or the economic aspect of producing feed locally. So this is the main goal, is to understand the economic feasibility of producing feeds in Hawaii. One of the important issue that we want to address is first to actually really want to know how much feed we really need in Hawaii. So that was like our first research goal last year, was to estimate the feed demand in Hawaii. We conducted a survey last year for the aquaculture producers. However, we don't really have enough information, enough responses to accurately estimate the feed demand. We do have the rough estimation of the feed demand in Hawaii. So after understanding how much Hawaii needs feed, we now develop an economic model to calculate the cost to produce the aquatic feeds in Hawaii. To start, we use the Microsoft Excel to create the model, because we feel that with the Excel, we can have much flexibility for the users later on to input the parameters and change some values as needed. So in our study here, we used two scenarios. We look at two fish species, the tilapia and moi. The tilapia, we looked at the feed formula of 32% of crude protein and 6% of crude fat. And for moi, the feed formula is 48% of crude protein and 12% of crude fat. And then we calculated the cost by looking at two different combinations of feed ingredients. The first one is we produce it in Hawaii, but we imported 100% of the feed ingredients. And then the second one is we produce it in Hawaii, but a portion of the feed ingredients are sourced locally. All right. So when we start to develop the cost model, the initial idea is we would like to start from scratch. We would like to imagine how much does it cost to build a feed mill using current cost situation in Hawaii. So unfortunately, when we tried to do that, it was very difficult to collect the current prices because when we contacted the manufacturers, it was not very easy. They are being a bit reluctant to provide information. So because we need to go on with the project, the alternative was to refer to the cost data from the existing feed mill, which is the OI feed mill, the Oceanic Institute of Hawaii Pacific University feed mill. That's a feed research and pilot production facility, and we'll use the one that is located in Hilo, Hawaii. And from there, we also complement the data with cost data that from the literature review that looks at feed mill cost as well. And I also did some internet searches to look at some current information, property tax, interest rate, and in Hawaii. The challenges are, first of all, even with this alternative steps, there are not enough publicly available documents. The main document that I used was the Oceanic Institute's business plan report published in 2012. And that has been my main reference to look at the cost components and the cost value as well. And also, one of the reasons also why it's a bit difficult was perhaps there are some personnel turnovers in the OI. So prior to developing the model, it's very important to establish some assumptions to help us understand how we come up with the estimated cost and under what kind of conditions. For this study, we use a lot of the assumptions that are used from the OI document. So for example, the OI production capacity is 408 tons for the first year, and that's what we use for the model. And then for property tax, interest rates are from the internet searches. But of course, these are all of these assumptions can be changed accordingly later in the model, in the spreadsheet. There are many costs when you need to consider when you develop a feed mill. But basically, there are three major cost components. The first one is a preparation cost, or in some literatures, they also refer to as construction cost or investment cost. This preparation cost consists of several subcomponents as well, such as land, building, equipment, architectural, and engineering, which I will explain in the next slide. The second component is fixed cost. As you may know, fixed cost refers to the cost that doesn't change over a period of time, even when you increase or decrease the number of production. As variable, for the third component, the variable cost, this one actually, as it reflects on the name, it's very depending on the company's or the feed mill's production. So the cost may rise as production increases or fall as production decreases. Excuse me. So starting from preparation cost here, on land, when you build like feed mill, definitely we have to consider the cost of land. Since in the OI document, it says that it actually rents 1 acre of land in the Pane'ewa agricultural farm. So I refer to the current cost of land purchase, but you also can consider of land rent as well. And then the next one is building. So in a feed mill, there are different types of areas in the building. The first one is the mill area, or you may say like the feed processing area, where you have different rooms. But definitely some of the key rooms that you have to have is the electric utility room and the feeds or feed ingredient storage room. We also have boiler room, grinding room, an open separation, and some support areas. The last one is exterior utilities. So we also have to consider that in our budget, like how much is the cost to build the road, parking area, and etc. The next subcomponent of preparation cost is equipment. For equipment, we actually have a long list of the type of equipment needed in the feed mill. But here I just show you the flow of the machine equipment here, from receiving, grinding, batching, and mixing until pelleting. And then the last one is the architectural or engineering, where we have to consider the cost to do the design, obtain permit services during the construction, and also implementing the environmental impact assessment, or EIA. So this is how the cost model looks like in the Excel spreadsheet, and this is just a snapshot of how we calculate the information. So for example, here, land on the second row from the top, we looked at how many square feet is needed, and then the price per unit, and then we calculate the total cost. And if there's the right hand column, the two columns on the most right side is basically how to calculate the depreciation value, which we will use later on the fixed cost. So we add this cost all together, and then we add also the contingency fee, because in building a calculating a cost, we do need to spare some additional budget. This is the same as well. I just want to show you the list of equipment. Here is the list of equipment investment for feed production. As you can see, some of the costs here, we couldn't obtain the information. So I refer to the OI document to look at the equipment cost that was reported, and then I adjusted with the current 2022 inflation rate, and also added up with the contingency fee. And this is for the architecture engineering costs. I'll just skip this one. Okay, so the next one, the second component is fixed cost. So a major portion of the fixed cost arises from the mill investment cost. The initial investment of the equipment, the building is spread out over the useful or productive life of the durable input. So for example, here, the prime example is depreciation of building and equipment, and other costs under fixed costs that we have to consider are property tax, insurance, and interest, as well as some transportation costs. Okay, the last component of cost here is variable cost, which will vary depending on the amount of feed that we want to produce. The subcomponents are feed ingredients. We also have to consider shipping cost of the feed ingredients and the labor. Here we have to be very careful in defining the number of workers that we want to hire, and look at the different types of workers. For production workers, for example, it really depends on how many you want to produce for the feed. But other type of labor, such as management, they might not change with the feed production, because they are paid based on salary. Other variable costs here are utilities, costs to repair and maintain the equipment, some supplies, and interest on operating capital. again, this is the snapshot of our model of the calculating the variable cost and the fixed cost. I have to say, like, since this is still like preliminary, a lot of the cost here may maybe not complete yet, and also maybe not really reflect the reality of current situation, because some of the cost that we got from the OI is from 2012. Okay, so towards the end of the calculation here, I summarize the cost, as you can see here, for each fish species. So for tilapia, you can see there the two columns here. The first one is the cost when you imported all the feed ingredients, and the other column, the right hand column, shows if we combine it with 34% of local ingredients. When you looked at the total investment cost, it doesn't change because it is investment costs remain the same regardless of the production, the total amount of production. But for the annual cost, we see that if we source from local ingredients, the total cost is lower than if you import 100% of the feed ingredients. And then for MOI, it also looks similar when you look at MOI that imports all the feed ingredients, and with MOI that source half of the ingredients from source it locally, the total annual cost is lower. And I try to compare, in addition to looking at the combination of cost if we import 100% of the ingredient with cost if we source some local ingredients. And I add also if we purchase the readily made feed, like how much does it cost per pound or per ton? So for tilapia, it looks like the cost of producing feed in Hawaii seems to still be higher per pound. But when you looked at MOI, it's interesting to see if you purchase the readily made feed, the cost is similar, more or less the same with the one that if we produce it in Hawaii and 100% import the feed ingredient. Just to also bear in mind that this doesn't include, for the readily made feed, we don't include the shipping cost yet here. This is when you just purchase the feed. So this is going to be my last slide to just show the takeaways from the cost of producing in Hawaii from our study. It seems that the cost is still higher if we producing feed in Hawaii compared to if we purchase the finished feed product. But if we produce it in a larger quantity, there might be an economy of scale, and that we might be able to reduce the cost. But that also begs the question that how big a feed mill should be to be able to meet the feed demand in Hawaii. With that, I would like to end my presentation, and I'm happy to answer any questions or if we can discuss. Thank you.
Wow, thanks so much, Sita. Thanks for developing that model, and we'll field some questions from the audience now. So go ahead and speak up. And Pomai is asking if you would be able to make a copy of your data available.
Yeah, of course, I will definitely would be able to share like this presentation slides, and if you want like the data, I'll be happy after I discuss with Dr. Lee. Sure.
Yeah, thank you. Other questions? I guess I have a question about the model and its availability. So do you plan to publish the model for others to be able to use, or?
I believe, and Dr. Lee, you can like add more later. I believe that that would be our main goal, like later on to share this spreadsheet. So then the users can, you know, like play around with the numbers and the figures, but all the formulas are there and all the assumptions are there too. So you can estimate it by yourself, the cost needed to produce the feed in Hawaii.
Thank you. Yeah, I'm curious to hear from some of the people on the call if anyone has been thinking about producing their own feed and you know, sort of looking at costs. Does this line up to what you've also been seeing?
Yeah, I should just stop sharing.
Or perhaps any other questions that the audience may have?
Yeah, I have a question. So great job, Sita, congratulations. So this is on the assumption that the feeds are going to be manufactured in the Big Island, isn't it?
Yes, correct.
Is there any, or do you have any idea how much it will cost to ship that potential feed to other islands or other places around the region?
Yeah, honestly, I haven't. Yeah, it's already like in my mind, but I'm still working on how to, you know, like figure out how the cost of like shipping it to other islands. But that's a really great question, and I think it's important to address as well.
Perhaps someone in the audience may have an idea of how much
Yeah.
that costs to ship. I don't know,
Yeah.
a container. I don't have it yet because we don't do
Yes.
that. Maybe interesting if someone else may have that information.
Yeah, is anyone able to respond to that? How much the cost for shipping within the islands?
It would depend on volume and frequency. You can work deals out, right, with all the shipping companies, and if it needs to be refrigerated or non-refrigerated. With Fresh Island Fish, we were shipping in refrigerated containers, and you know, I mean, it can go by pound, it can go by volume. I think it just depends on how much and the frequency.
Thanks, Crystal, and thanks, Dr. Armando. Let's see now, there's a question in the chat from Michael Rust of wondering if you did any sensitivity analysis on the model.
Oh, thank you. That's a very good question. For now, this is what I've done so far, but doing a sensitivity analysis is definitely one in the part of our research study. I'm not sure like what kind of sensitivity analysis that you're talking about, but I tried to do like different amount of production and see how much it changes the cost, but I haven't really looked like how much significantly it changes.
Thanks. I couldn't find my raised hand button, so I appreciate the answer. I was really looking for some idea of what's driving these costs, so that those areas that are most important to that break-even line could be kind of worked on and targeted. And I wasn't clear, as long as I'm talking, I wasn't clear whether you had a specific formulation of a feed where you could bring forward the cost of the local ingredients versus the imported ingredients and do some kind of analysis on that, because obviously some imported ingredients are going to, you know, have much more expensive routes to get to Hawaii than others. So I'm just curious where the diet formulations came from.
Thank you, Michael. So actually for this feed formula, oh, Dr. Lee, you raised your hand. Do you want to?
Yeah, maybe I can
Add
jump
something?
into the,
Okay.
make some comment to answer that. Mike, thank you so much for your comment. And actually, I want to say this way, the product, what Sita just present to you guys, really quite far from the initial idea what I'm trying to do it. And again, some of you guys probably know that I'm a biologist, I'm not an economist. So I have to, before I say something, I have to thank my team working members, the economists that helped Sita to come out of the model. So the original idea, what we try to do is we thought we conduct a survey and we'll be able to understand, get a close estimate of how much feed we needed in Hawaii. But the end up is like sort of kind of disappointed. We didn't really get the amount. And the second is we try, as Sita mentioned about, we try to build it based on the demand and they build it a new feed mill and to see how much it will cost to produce in that one. And when we contacted the manufacturers and talking to many different companies, and Sita and I, actually, we've been chasing around, it's so difficult, and the manufacturers somehow they are reluctant to provide us with a number. So we couldn't do that. So we take another approach is say, okay, how about do this way then? Can we just using the existing OI research feed mill and to see can we using them to produce the feed and to see how much it will be cost. Then when we do that, and as Sita mentioned about in her presentation, some of you might wonder and say, hey, you don't have any data inside each different component. So the idea is this way. I told Sita and talking to the team members, they say, okay, how about we just develop a model? And the model will be allow for whoever want to build it, a female, to feed into, to plug into the data inside there. And so then they can say, for example, like labor cost, like equipment cost, or building cost, the land cost. So you can put those on, and yet this model will calculate how much, what the fixed cost, what the variable cost, and so on, those values, then you will be able to calculate that. So that's why the end up we do the model there. And Michael, your question about the sensitivity analysis, that's exactly analysis. The original idea we try to do is, as some of you might know, that CDSA has funded many projects to try the alternative protein source from the recycle or whatever means to producing the protein source locally, using local waste to produce the protein. So the original idea is try to see if we using whatever particular ingredient, either from fish processing or from some of the like cyanotex, for example, their waste and so on, and have it up price and to replace, to using this one to link in with this model, then to see if we replace the protein, how much percentage and how that will affect the production cost, and using the sensitive analysis, try to figure out, say, okay, if we want to make it even the break-even price or the price the same with the mainland imported, and how much we need to find a local resource of the ingredient in order to make it sense. So that's all the ideas. So I have to say is we really have originally have a really good intention, try to get something probably more useful. But when we run into actually try to put everything together, we found out there's so many challenges, so many difficulties, we're still unable to do that. So as we speak, and Sita will continue to do that, and hopefully by end of 2023, we'll be able to make this model more user-friendly and have it provide more information inside here. to make it more make sense for either the policy maker in Hawaii or whoever, or the commercial entity try to build it, the female in Hawaii will be able to take the preliminary first look at it to see whether it will make sense to produce it in Hawaii or to import it just from mainland by other means. So that's, I hope this will achieve. And in 2023, another thing we'll try to implement is try to hold a meeting and maybe even ask Jane to help out to get the stakeholder together, interested people together to really talk about how we're going to solve the fee issue. Because that's it's a top one when I conduct a survey about what's the most important roadblock in order, we need to overcome in order to have an aquaculture development in Hawaii. And so we'd really like to have a more stakeholder input in order for us to do something will make sense. But if stakeholders don't say anything, and will be very difficult just from what we imagine what the solution and so on. So again, we'll try to early in 2023 to hold a stakeholder meeting and really to sit down to talk about what's the best solution for the fee issue in Hawaii, to solve it by producing locally or to using the other means to overcome the fee issue. So that's what we'll try to achieve. Okay, so I hope that answered some of you guys' questions. Thanks.
Thank you, Dr. Lee. Any other questions from the audience or follow-up questions for Dr. Lee or Sita?
I was going to make a suggestion that if you're looking for more data on costs, that you could approach some of the companies that sell the feed mill components, since they help all their customers model out these things anyway. That might be a suggestion to get more data.
Thank you.
Yeah, thank you, Dylan. Have you guys explored that at all, Sita and Dr. Lee, is approaching the distributors or the companies that sell feed?
So no, they don't sell the feed. The companies that build and sell the components for the feed mills.
Like the machinery equipment.
Yeah.
Yeah, that was actually what we did as well. We tried to contact some of the manufacturers, but as Dr. Lee mentioned, like in the end, it was just end up didn't get the information because they were a bit reluctant to share. So I don't know if you have any like suggestions, like specific suggestions to reach companies, or like yeah, I mean, any information would be very helpful.
Sure, just reach out to
basically, me. Sorry, yeah, go ahead. Yeah.
No, I was just gonna say, reach out to me on another call and I can give you some introductions to people.
Sure. Yeah, that's what would be appreciated. Yeah, when we talk to the feed, the equipment manufacturer and so on, the first question they will ask is to say, how much, what's your production, what you needed? And they are talking about when are you going to have the female, and after several conversations they end up with, when we told them, say, no, we just do the research, try to figure out, and they end up, they kind of, I guess they didn't see the business will come into their side deal, so they don't want to spend the time and even to tell us. And I even ask and say, can you just give me the rough how much the equipment costs and so on. And we even have a very difficult time to get those data as well. They say, oh,
exactly.
You need to, so on. So anyway, it's more complicated than original I thought about. So anyway, I think there was someone raising the hand. Comment.
Yes. Thanks so much for the question, the comment, Dylan, and for connecting Sita and Dr. Lee with your contacts. And Pomai, you have a question?
No, hi, thanks for inviting me on to this forum. And I just wanted to let everybody know, my name is Pomai Freitas. I have an animal feed project with taking invasive species and byproducts on the island, making animal feed. I am currently the licensed manager and putting the Big Island feed mill back into production. We've been working on a deal with HPU and Oceanic Institute for the past 2.5 years. We finally locked in and got our contract going as of November 1st. So we are in the feed mill working, trying to get it back up and running. There is a lot of what ifs about the feed mill. The construction of the feed mill wasn't thought out the best that everybody thought it was. So yeah, we're working on the feed mill, trying to get it up and running. So if at any point in time you guys get questions, feel free to ask me.
Yeah, that's wonderful. Pomai, can you have your contact information at the either the chat box or something, so we can get hold of you, talking to you?
Yeah, absolutely. I'll put it in the message box below.
Thank you.
Thank you so much, Pomai. And
Mahalo,
also, Dylan,
Pomai.
I hope we can also have your contact too, like for me to reach out to you. Okay.
Great, thank you. Crystal, do you have a comment or question?
Yeah, this is for Pomai. Hi, this is Crystal with Hatch. I was wondering what ingredients are you guys, or what byproducts are you guys using, and for what animal feed are you creating the feeds at this point?
So we are focusing our first trial, which is actually starting up in 3 weeks, 3 to 4 weeks. We're going to focus on pigs for the first trial. The back end of that trial, we are working with Alexia and Ambrosia on the cattle study for methane reduction, and we're looking forward to go with whatever we can do. We can get cattle, pigs, goats, sheep. We're also looking into aquaculture and chickens. We're just trying to do whatever we can to help. Our byproducts that we're using right now for this first trial is we're using a gorse, macadamia nut shell, and algae mixture.
Great, thank you so much for that. And then I missed, what company are you with, or who are you funded by?
I have a nonprofit. It's Hui Ho'ola Ko for Hawaiian Initiatives. We got funding through the legislature this past year. We also have a County of Hawaii innovation grant that actually started the seed money for us.
Wonderful. Thank you so much, and good luck. We're all looking forward and rooting for you.
Thank you.
Yes, thank you. Okay, any other comments or feedback or questions for Sita at this time? And Pomai, if you could drop your contact info in the chat, that would be wonderful too. And we'd love to have you talk about your trial when you're ready. That would be quite interesting, I think, to everyone, and to get an update on how the feed mill is going.
Yeah.
But yeah, thank you. But at this time, we've gone over, but thank you for sticking around. It's such an important conversation, and mahalo to Sita for sure. And yes, the recording of this will be available on our website, hiaquacollab.org, under our actions page. And Sita and Dr. Lee, thank you for the wonderful work you're doing, and we look forward to collaborating with you on this topic in the future. All right. Take care, everyone, and happy holidays.
Thank you, Jean, and thank you, everybody.
Thank
Happy
you so much,
holidays.
everyone. Happy holidays.
Yeah, thank you, everybody.
Hey, Pomai, you just want to give me your email address? Would that be easier?
I just put it in the chat for everyone.
Okay, great, great.
Yes,
Thanks
I
for
just
trying to-
copied it. Thank you so much.
Oh,
Pomai.
awesome. Thank you.
And thank you so
Yeah.
much, Jean.
Thank you, Sita. Great job. Hope you feel better.
Thank you.
All
Have a
right.
good holiday.
You
Take care.
too. Take care.
Bye-bye.
Aloha. Bye-bye.
Hello.